In this video, I am going to discuss about even and odd functions. Let's consider the function y is equal to f of x. We'll call this function an even function if f of x is the same as f of negative x. That means replacing x by negative x will not have a change in the value of the function. Here is an example, very easy example that we have been dealing with. Y is equal to f of x is equal to x squared. If I replace this x by negative x, then what happens? It's going to be negative x whole square, which is, by the way, negative x times negative x, which is just x squared. So it doesn't change. So I could give you a simple example. Let's say x and y. If x is 1, y is going to be 1 square, which is just 1, right? If x is negative 1, y is going to be negative 1 whole square, which is just negative 1 times negative 1, which is just 1. See, doesn't matter what the input is, either 1 or negative 1, the output or the y value of the function is always 1. So y is equal to x square. This is an even function, or any even power of x. So things like x to the power 4, x to the power 6, x to the power 8, these are examples of even function. Or I could have something like this, x to the power 4 plus 2x square. This is also an even function, because if you replace x with negative x, it's not going to change the value of the function. Now let's talk about odd functions. So we are going to talk about odd functions. So if you have a function f of x, okay, y is equal to f of x. Now if you replace x by f of x, replace x by negative x. So if I replace x by negative x, so this x is being replaced by negative x right here. The effect of this is multiplying the original function by negative 1, which is f of x negative. So negative f of x. So if you have function or a class of functions where if you replace x in the function by negative x, it becomes negative f of x, meaning it's as if you're multiplying the function by negative 1. So here it is, an example. Y is equal to x cube. If I take this function and replace x by negative x, I'm going to get y is equal to negative x whole cube, which is negative x cube. You can do the calculation. Negative x whole cube is negative x times negative x times negative x, which is negative x cube. By the way, negative x cube is just negative x cube, of course. It's going to be negative y, right? So let's write it here. So in this particular case, we just found that f of negative x is equal to negative f of x. And one class of easy functions that you could think of that are odd is x cube, x to the also x, right? X to the power 5, x to the power 7, and so on and so forth. You can see these functions are odd functions. Why are they odd functions? Because f of negative x is negative f of x. Now let me talk about a couple of other properties of even and odd functions. For an even function, by the way, for an even function is symmetric about the y-axis. Here is an example to show you what I mean by that. This is our favorite function, y is equal to x squared parabola going through the origin 0, 0, right? That means the vertex is at the origin. Now, what does it mean to be symmetric about y-axis? Meaning that the right side of this function is a reflection of the left side, or the left side of this function is a reflection of the right side about the y-axis. That's what it means to be symmetric. Okay, symmetry is a very important feature of a function, important characteristics of a function. You should pay closer attention to this. So even functions are always symmetric about the y-axis. Why is it symmetric about the y-axis? Because it doesn't matter whether you put negative x or x as an input to the function or as a value to the function that's going into the function. It's irresponsive to positive x or negative x. That means if you move to the right or to the left, it doesn't matter. By the same amount, y value is going to be the same. So that's why it is symmetric about the y-axis. Similarly, odd functions, you can guess what's going to happen. It's going to have another symmetry. But this symmetry is, if you're guessing it about x-axis, no, it is not. It is actually symmetric about the origin. That means symmetric about the origin. Our example of symmetry, we could use this function, this x cube function. This is symmetric. This is an odd function, so it's going to be symmetric about the origin. So once again, let me summarize what I have talked about. We talked about even and odd functions. Even functions have the features f of negative x is equal to f of x. So f of negative x is equal to f of x, even functions. And odd functions, f of negative x is equal to negative f of x. Odd functions. Okay. Now even functions are symmetric about the y-axis and odd functions are symmetric about the origin. I hope that this discussion was helpful. Thank you very much.